Good afternoon, everyone. So, we will resume from where we left in the previous session. Okay. So, we were looking at the list comprehension techniques. All right. In that, we had seen three different methods, right? So, they are, right? The first one was mapping, and then we actually checked at what is called as filtering, and then we checked, right, the third method, right, that is called as a reducing. Okay, now, so our next objective is to look at another example. All right, so let's look at an example so that we can try to recall, right, what was the last topic that was dealt in the previous session. All right, so I'm trying to I have to bring in the func tools, because I'm trying to give an example on the reducing part. Okay, so let's look at the reducing once again. So I need to import the func tools, because inside the func tools you have what is called as the reduce function. All right, so before that I want to let's say I'll try to write a question here, right, so that we are trying to answer that particular question now. So we have certain elements in a list, right? A list is given, you try to form a list, and we want to apply any of the technique that we have learned so far. That is, you can use a reduce, you can use the filtering, or you can try to use a mapping, right? So that we'll try to get the LCM of, right, the elements in a list. Irrespective of the number of elements that are present in the list, I need to get the LCM of that. So you see, whether you have two numbers, three numbers, 10 numbers, or whatever, right, the LCM is going to be a single number, right? A one single answer I'm supposed to get. That actually indicates that uh, the function which I'm supposed to apply here, right, is reduce. Because if you try to use a filter, you get many answers, many elements, because you give in a list comes as output, right? At the same time, if you try to apply the map, right, the size of your list will not be reduced, right? Every element you are trying to do something, right? And you get the answer also in the form of a list whose size is equal to the size of the original list, correct? So because of that, we cannot apply them. We have to go for the reduce function. Okay, so let's see how to do that, right? Okay, so I need to go for a LCM now. LCM calculation happens, right? What's the easiest formula? If I have two numbers given, say m and n, what do? How do you find out the LCM? What is the approach? What's the algorithm that you are going to use? Anybody? How do you do that? What is the maths behind calculation of LCM? Or if you are able to tell me an equation, I prefer that. Okay, please go ahead. Meanwhile, I'll try to bring in what I require for that. I need to import a math tool over here, right? Just before I do that, right? So yes, what is the equation, so that what is the equation that you can use to calculate LCM, or what is the logic that you're going to apply to find the LCM of two numbers? Okay, so I'm giving two numbers as input. You have to calculate that. Okay, so yes, anybody? Please go ahead.
Product of two number divided by HCF of two number.
Perfect, right? So that's the easiest way, right? I appreciate that, right? So P. Okay, so let's go ahead, right? Let's try to implement the same thing here, right? So I'll write a function, right? Anyway, the functions we have not touched yet, but right now I have to use a function because I'm trying to apply a function for each and every element in a list. That's what I'm trying to do here, right? So because of that, I don't have any other option than writing a LCM, right, as a function. Okay, so I'll try to define. So define my LCM, right? What I do, I'll pass two numbers, right? I have to pass two different numbers here. One I'm going to call it as M, other one I'm going to call it as N, right? So, right, as per our semantics, it gives a space of, right, certain units over there, right? So what I'm supposed to do, I just have to return, the product of two numbers as Tripti told, M into N, and see, LCM of a number, whenever you calculate, it has to be a whole number, right? How do you take care of that? You perform divide by divide, double twice. Once if you divide, it may, there is a chance of becoming the float, right? I don't want that, right? I will try to get an integer part of it. What you are supposed to divide, you have to divide by the GCD or the HCF, right? So greatest common divisor, right? So let's use that. So that's why I imported math over here. Math supports the calculation of GCD directly, right? So this is MATH, math. Inside the math, you have what is called as G. Let's check that. So you see, as I press the tab, it suggests you have a gamma function available, you have a GCD available. Just come down, get a GCD and GCD of n comma n. So it automatically calculates m into n divided by, right, the integer division, right, of the product of m into n and the GCD of m comma. It will be calculated and it will be returned. That's all, right? So LCM part is done. But now you see what I'm supposed to do here. I'm supposed to, okay, let's check whether this function works or not. Okay, I'm trying to calculate in the LCM, right? I'll apply my LCM for two numbers, say 2 comma 13, right? 13 into 2, 26 is expected, yes. So you see, we get that. Fine. Now I want to find I want to apply the reduce to a list of numbers. Right? So just use it. See the func tools. Inside that I have reduce. Right? This is coming from the yesterday's right discussion. What I have to write first. I have to tell which function I want to apply. That is my LCM. Apply this to a series of numbers. Right? You have to pass at a list. So this is a list of, create a range. All right, create a range from 1 to 11, that is 1 to 10, right? If you know any other method to calculate this, you can calculate and verify this answer as well. Okay, so you see I'm going to get only one number as an answer. That's the LCM of all the numbers from 1 to 10. Okay, so 2520 is the answer. So right, these three things are pretty much important. That's why I'm trying to repeat that, right? So the first one was a map, second one was filter, we discussed yesterday. The last part we discussed was the reduce part, and now we gave an example for that as well. Okay, so just check if you have anything, right? If you have any doubt, right, you can ask now itself. Okay, so next to that we have what is called as, right, this is what we're going to discuss next. That is called the set comprehensions. We are trying to apply something on sets, right? So try to recall, we had the sets, right, defined like I may have any number of repeated values, right? I will try to write one of them at a time, and I'll put it into a variable. We call it as a set because it cannot have repetitions. So let's try to create a set now, right? I'll try to create a what you call as uh, right. I'll try to form a string over here, and without repetition, if I try to write that, it becomes a what you call as right, the set. Okay, so I'll try to create maybe my string is equal to, okay, a, let me try to write a few more say words over here. E, yes, Okay, then I have a B, name, all, etc. Let's say, okay, this is my string. Now, uh, one option, I'll show you two things here, right? The comprehension can be applied in two different ways, right? The first way is I'm trying to create, right? Let's say I want to calculate length of x, right, for every x that is in my string. So what it does, it finds out x in string. X in the string means what? X in my string. What is my string? My string is a list of strings. I have given a name like my string. So each element inside that list is, right, a string. Like A is the first string, then he, second string, then yes. So when I say x in my string, right, x in my string means this is the first x, then the next x, then the next x, because it's a for loop. You know that already we have discussed a for loop. The speciality of for loop in Python is that you don't have to go with only integers here, right? You can even, right, enter a string. You can write a for loop for strings also. So that's what was the advantage we discussed, right, in the previous session, right? So you see, x for every x in string means for every entity that is present over there, find the length of x. So I'm going to get that as my answer. So just see here, right? You are trying to find out the different lengths, right? So you see, answer comes 1, 2, 3, 4. Not every entry. You are not getting every entry over there, because there are two strings A and B with the length equal to 1, correct? But you know that I'm trying to create a set now. I'm not creating a list. If you try to create a list, every value will be coming like 1, 2, 3, 1, 4, 3. That's what was expected if you are trying to get list comprehension. But right now it is not list comprehension. I'm trying to do a set comprehension. In the sense, the result is expected to be a set. So you see the difference now. I'll try to do the list comprehension. So this is the length of x for x in my string. Okay. Okay, there is a mistake here. So I need to put this close bracket over here. Okay, so yeah, now you see, right? So this is a list comprehension, because I'm trying to create a list out. Input is a list, output is also a list, and I'm trying to apply what is called as a map. I'm trying to map a function to each and every element in the list. So that's what is in the line number 8. But line number 7, you see the curly braces, which indicates that the result is a set. So see the difference, set comprehension and the list comprehension. Okay, so any doubt you have, please let me know, right? Otherwise, let's proceed further. So more details of these comprehensions you can find in uh, the notes that have been shared, right? Yesterday after the session. Okay, so look at that. Please concentrate more on that. Go through that, understand. If you have any doubt, please feel free to ask. Okay, so next directly I'll move on to what is called as, this is very important. It's called as a function. We are going to look at the functions in Python, right? So let us say I anticipate to repeat a part of my code again and again, more than once. If you are using something only once, don't write a function. But in a code, right, you anticipate the necessity of repetition of a part of the code. That can be 1 line, 2 line, 10 lines, whatever, right? If you anticipate that, right, then we'll try to write that particular part of the code. In the sense, those 10 lines which I want to repeat again and again, I'll try to write it as a reusable part of the code called as a function. Functions are reusable part. So readability of the code can be increased if you use the functions. Okay, so why do you use a function? That's the answer. Okay, so how to define, right? So I need to define a function, right? So definition of a function goes like this. Let me try to write a very simple example now. So def is the keyword. To justify that, I'm trying to define a function now. So after def, give a space, white space, and enter the name of the function, right? Normally ABC, XYZ, my name, your name, anything can be given there as a name. But the convention says that you have to give a name in such a way that somebody else who is reading your code should be able to understand what you are trying to do here. For example, I'm trying to write a squaring function, right? I'm trying to write a function which actually performs the square of its input, right? So whenever my intention is to do that, let me try to go ahead and do this. So I try to write as my sq my squaring function. Okay, this is my squaring function, and I'm trying to pass a variable n to this, right? So this is what is required. If you write this much, it is sufficient, right? The compiler understand that, okay, right? You are trying to write a function, but in order to increase the readability, whenever somebody else reads this, right? It is expected, right? Python 3 onwards, right? You have a facility that you can enter what you are trying to give as an input and what is your output. You can actually mention that. For example, after this, you write a colon, n colon, specify what is the type of this. So what happens when the program runs, after this n colon, whatever you write, it will be neglected, right? Automatically, it is written in that way. So, but when somebody reads this code, they will understand that n colon means n is a integer. Input is expected as input. Then whatever comes as output, right? So I can try to write that by using a dash and arrow, right? And you tell this function return something, right? So that return part is also integer, because you give an integer, square of an integer is always okay. So this part is optional, right? So you want to make it more readable, yes, do something like this. Otherwise, this part and this int, the colon int is, you can remove that. But the colon that is presented last is absolutely necessary. Okay, so why so? You know the answer, right? Because after this, if you press enter, it understands that, okay, I'm going to be inside this function. Okay, so that's the reason why. Okay, so then return, what I'm supposed to return, the square of a number. How do you write that? It is n power 2. You can try to write this, or much easier way, simply write n into n, because you are trying to write a squaring function, right? So just run that, you can see that yes, this run, right? It compiles. Now try to call the function. Now what I'm trying to do, I'm trying to call this function. So calling a function is pretty much easier. You just have to see the name of the function, and you have to see what is inside the brackets, because you should know what you are supposed to pass, right? What variable you are supposed to pass. So when a variable value is passed to that variable, it will calculate the required values and provide the answer. So you see my squaring function of, let me pass 10 to this. So run this, you can see 100, right? Now, though you see, you have entered that I want to pass integer to this, right? Normally n is an integer. Output is also integer. But what now, definitely, obviously, you have a question. What happens if I change this, right? I'm saying that I'm passing integer, but what if I pass a floating value? So what happens is the output type or the return type that a function, whatever type of the variable or value that function is going to return depends on the input you give. So you give a float, output automatically gets converted into float. It will not throw an error. All right. So just check this. Okay. So my squaring function, and I'm trying to pass 11.21212. So you see, answer is coming as a float, right? Let me show you, demonstrate this in the different input. My squaring function, I try to write, this is minus 33 point, right, 998 j. So what do you expect? Answer should be in the complex form, right? So minus 1155 point so and so plus 0j. Though the answer is real, it is going to generate the answer in the same format you have entered or in the same input argument type. Whatever is the type of the argument you pass, it generates this. So there will be no error, right? Don't worry. But this is just trying to tell whoever is reading your function that this is what I'm expecting. I'm expecting you to give an int as input and int as the output generated by this particular function. Okay, so functions are pretty much simple, right? Let's try to let's try to write a function now, right? This is the question. All right, so please try to build your logic, right? So I'm going to ask that question now. So this is what I want. I want to write a function to find whether the input argument is prime number or not. Okay, so I'll enter a number. I want to write a function, right? The function is, right, to find out whether the number entered is prime or not. So your answer is yes or no. That's all, right? So what is the logic? What's the logic? How do you find out a entered value is prime or not? Anybody? So what do you mean by prime number? A number which gets divided by itself and only one, right? No other number, right, should be able to divide that particular number. So 2 is prime, yes. 3 is prime, yes. 4 is not prime because it can be divided by 2. 5, yes, it is prime because it can divide by itself and only one. 6 is not prime. 7 is prime, right? 8 is not prime. 9 is not prime, right? 10 is not prime. 11 is prime, yes, and so on. So you know the prime numbers now. Now, as I enter a number, right? How do you identify that it is a prime or not? What logic you are trying to build? So prime numbers are very important. So that's why I'm trying to give an example of prime itself. Yes. So I want an answer. At least attempt, right? I'm not expecting you to be very perfect on that. So at least try to attempt, right? You may have many chances, right? You may have to check many cases over here, right? But what is the general idea? You understood what is a prime number, right? So I give a number as input. You just have to find out whether that number is prime or not. So if a number is divisible by 2, is it prime? It is not prime. If a number is divisible, anyway, 1 I neglect. I don't start from 1 because you can divide every number by 1. So I'll start with dividing a number by 2 and 3 first. Okay, this is my logic. You can even apply any other logic which you try to find, right? A better one. Okay, so let's build step by step. So I'll try to define my function. So I'll call the function as prime or not. Okay, and I'll pass a x as input, right? I'll say that this is int. I'm passing an integer value and the return answer is yes or no. When you have only yes or no, what is that type called? That type is bool, right? So my return value is a Boolean value. Oh, sorry. My return value is a Boolean. So I put a colon and then I press enter. Now I am inside the function, right? So first I'll try to check that whether the number is 2 or 3. If x in the sense the x which you have entered is 1 of 2 or 3, right? So I'll check this whether it is 2 or 3, right? Directly return false. I'm saying that it's not right. It's not a prime. Return false. All right. So that is that. Sorry, my mistake. 2 and 3 means it is true, right? Sorry. Please correct me if I'm wrong. If I'm wrong. True, right? Because 2 and 3 are prime, right? So I return true, right? So next part, I'll check, right? Whether a number, any number I have entered, I'll try to make sure that whether that number gets divided by 2 or not. Okay, so if x percentage 2, it's a modulo operator equal to 0. In the sense when you In the sense, when you divide that number by 2, the result is, right, the remainder is 0 or not, I'm checking. So if this is the case, right, return false. Sorry, F should be capital, right? I return false. Now what I do, next I'll keep checking whether I'm able to divide that number by 3, 4, 5, 6, etc. Right? So how do I do that? Right? See the logic, right? I'll define that factor is equal to 3. From 3 I'm starting. Right? While, right? While the factor into factor, right, while the factor into factor is less than or equal to that x, right, the square of the factor. For example, if you see, say my number is 9, right, what I'm supposed to do, I'll check that whether the number is in 2 or 3. It is not in 2 or 3, so I'll go to the next condition. I'll check x percentage 2 equal to 0, right. I'll check that whether that, right, number 9 is divisible by 2, right. That is not true, right. So it is not divisible by 2, so I'll go to the next part. So you see factor equal to 3. Now I just have to check that while the factor into factor is either less than or equal to 3, equal to x, in the sense 3 into 3, is it less than or equal to my number x? Yes, this is the case. Okay, in such a scenario, right, I just have to do one check, that is if, okay, the x percentage, that factor whichever you are trying to calculate, right, so x is my number 9 now, right now the factor is equal to how much? 3. So x percentage factor equal to 0, right, means what? If for example, if you take 9 means 9 divisible by 3, right, is equal to 0. The remainder is 0. So what is the case? It is not prime. So return false. All right. Under the if condition, I'll just check that if it is true, I'll say that it is not a prime number. So return false. Right. So next case is that, right, I'll try to increase my factor by 2, right? Factor plus equal to 2. I want somebody to answer me why I am increasing the factor by 2. In the sense, I had 3, so the next factor will be 5. I'm not going with 4, right? So after 5, next factor is 7 and 9 and so on. So I want somebody to think about that and try to answer that. Okay, so this is the case. This is how I increase the factor. And if all of them is done and still, right, you have a number, means that is right. So while this particular factor happens, right, you will say that true, because you are coming to the number which, right, is a prime, right. So that's why I return true. Let's check. Yes, this runs, right. So take an example of 10, right. I know that 10 is not a prime. So what happens? It will be compared with the base, right. So it is skipped. If x percentage 2 equal to 0, right, so 10 is divisible by 2, so that here itself you get answer. So return is false, indicating that 10 is not a prime. Okay, so I get an answer here, right. So let me check what I get here. Say, let me check 11, because I know that 11 is a prime number. So 11 is not in 2, 3, so this is skipped. 11 divisible by 2 equal to 0, it is not equal to 0, so this is also skipped. I start with factor equal to 3. Now you see, while the factor into factor is less than 11, so 3 into 3, 9 is less than 11, so this while condition is satisfied, I go inside the while. If x percentage factor, that is 11 divided by 3, is equal to 0, it is not 0, right. So I don't go inside this itself, I increase my factor. What happens to the factor now? Factor is 5, correct? Factor was 3, I incremented this by 2, but I still have to get an answer from you saying that why the factor is increased by 2. But I'm explaining the code now, right? So factor was 3, factor is increased to 5. Okay, so we have factor equal to 5, and when you have a factor equal to 5, so right, next check happens here. While the factor into factor, now what is the factor into factor? That is 5 into 5. 5 into 5, is it less than 11? No, it is not less than 11, right? So what happens? I come out of this loop. I come out of this loop and I'll say return is true because 11 is a prime number, right? I hope the code is fine. Working of this code is good. Are you understanding what's happening here? Yes, let me know if you have any doubt. Meanwhile, we have an answer from Sanath saying that even numbers are divisible by 2. So already that condition has been checked, right? If x percentage 2 equal to 0, we already say that it is false. There is no meaning in checking that again. Yes, that's perfect answer, Sanath, right? So that's why we are skipping, right? After 3, next is 5, next is 7. Okay, so like that, we are going to check it. So this is one of the logic which you can apply to find out whether a number is prime or not. Let's check whether this is working fine or not. Okay, what's the name of the function? Prime or not? Let me pass a prime number. I know that this is a prime, so yes, answer is true. Okay, let me enter another number which is not prime. Okay, it is not prime, false. All right, so any doubt? Okay, that's good. Let's proceed further. Right, the next option is what is called as a namespace. Right, so let's try to understand what do we mean by name space. So we have what is called as the scope of a variable. In the sense, I define a variable at what all locations, right, we can try to access that variable, or the variable is available for you to visualize or to use in a program, is called as the namespace, right? So whenever we create what you call as a variable, right, it's called as the local namespace. That's supposed to have a local namespace, in the sense, right, I can pass that to any function which I call inside my program, right? So that's a local space. In the same way, right, if you create a variable inside a function, once the function call is over, in the sense, once function returns some answer back to your calling function, right, you don't have that variable existing at all. You cannot access that variable. All right, so let me try to demonstrate this first, just to understand what do you mean by the namespace. Okay, so let me try to define a function. All right, define my function, right? I don't pass anything. Okay, I don't take any argument as input, right? I create what is called as a variable. Okay, it's a list, right? Then for I in range 5, right? 0, 1, 2, 3, 4, right? So that's the range 5, right? Variable dot, you know that what append is going to perform. I'll simply append I to my variable, then return. Oh, sorry, I have to come out of this, so I'll put a backspace. Return VA. So this is my function. I'm not passing anything to this. I simply can call the function, it will generate the output with it. Okay, so I'll just write my function, right? You don't have to pass anything. Okay, okay, so I have to give a braces for that. Parentheses are required. I call this function. You see, 0 to 5, the numbers are created inside that, because for I in the range up to 5, 0, 1, 2, 3, 4, variable, whatever where which has been created, it is empty initially. I am trying to append i's, right? Whatever I value takes it, I am supposed to append that. So initially 0, then 1, 2, 3, 4. This happens. I'm saying that return this var. So as soon as I call this, it actually, right, whatever is returned, it is printing that. Okay, but now you see, I'll try to check whether this var, what is the value of this var, right? So I try to either you try to perform an inspection or try to print var, both fine. Now you see it says var is not defined, but you will definitely say that I have defined var, I have used the var, but you see that is the scope of this variable. Scope of this variable is only inside this function. You can use the var only inside the function. Outside the function, that does not exist. So this is the local variable concept called as, right, local variable. Okay, so I cannot, right, use this particular variable outside the function where you are using it, where you have defined that and where you are using it. Okay, but let's say I have a situation wherein I want to use it even outside. What is the solution, right? Yes, we have a solution. The solution goes like this. I'll copy this, I'll just paste this. Okay, but this var is there, right? I'm going to make it what is called as global, right? Tell that this var is a global variable. Then you use that particular var inside your function. Okay, so this is fine for us. I will right, call my function. I'll call it. You know that anyway, this is going to work flawlessly without any problem, because it is. So this return var is inside my function, so it is printing that out. Absolutely fine with that. But now I want to check what happens with var. See, it prints out. Why it prints out now? Because I'm saying that this var should be available even outside the function. Okay, so that is the only way we can try to write like this. All right, then let's go for another very important concept, right? I'm not trying to give many examples for each cases, right? But yes, the material which has been shared has many things for you to refer. Okay, so please refer that for more details and more examples of everything that we are discussing. So the next concept that I'm trying to discuss now is, oh sorry, right, is let's say I want to discuss about how do you return multiple values? A function, as of now, we have seen that it either calculates LCM, it does something and returns only a single value. What if I want to return multiple values? Is it possible? Can I write multiple returns? Return A, then below that return B, return C. Is that way what we are going to do? Right? Just think about that. Meanwhile, I'll try to write a code. Okay. So I'll try to define a function to calculate say find quotient and remainder, right? So I will have to pass two numbers, right? One is n and one is n. Okay, and I'll write a numerator and denominator, n comma d, right? I don't want to specify the details like whether I'm passing integer, non-integer, etc. I'll skip that part, right? So I will try to return, right? How do you try to find out the quotient? Quotient has to be the whole integer. So numerator divided by denominator. Okay. Now, if you want to return only one value, this is enough, right? When you want to say that I want to return multiple values, simply separate them by comma. That's all, right? You don't have to go with any complex notation, any complex coding here. Simply write. I want to pass the right the reminder. Reminder can be obtained by using mod operator, n percentage d. That's all. Okay, so call the function, right? That is find quotient reminder and pass the numbers. Okay, so 100 comma 7, right? It says 14 comma 2, right? That's the correct answer. All right, so we understood that what is a function, how to define a function, how to call the function, and if the function returns something, how to catch that. So in this case, right, if I simply write like this, I'm not able to hold the return values in some variables. If you want to do that, simply do this. X comma y is equal to find quotient and remainder of, put any other number, 33 comma say 7. Now you see x is this, y is this. Okay, so like that we can catch the returned values from a function to be different variables. All right, so this is how you are going to do it. All right, with the functions, if you have any doubt, right, anything you want me to repeat or anything you want to, right, understand, anything you want to discuss, anything you want to ask, please go ahead, right? Meanwhile, I'll try to write what we are going to discuss next. So the next thing, we are still inside the function. There is what is called as the anonymous functions or lambda function, right? So this is something like, if you have a single statement, you try to write the functions consisting of single statement, and you can try to apply that to certain values, and you can try to make them to return direct, right? Directly you can use it as and when required. I'll show you how it is done. Okay, so that is what is called as a lambda, which is used as a keyword to identify that, okay, whatever I'm trying to write now is a special type of function, and it is going to have only one line of the code or something. Okay, so right, so lambda functions, it's a way of writing functions consisting of single statement, right, whose result itself is a return value. Okay, so you don't have to say return something, simply say lambda something. Okay, I'll just show you that. So let me try to write a my function now. So my function is equal to, if you are defining the result itself as a return value, okay, so you just have to say lambda. It's a lambda function. You see the color changes indicating that the machine identifies what is a lambda. Okay, lambda. There is only one parameter which is going as input to this particular function, x, and after the colon, whatever you write is its answer will be evaluated and returned back. For example, my squaring, I want to perform a square, right? So, right, I can simply write this is x into x. So see, it's a lambda function. Function different definition. There is no need to write define some name, etc. If your function is so simple, simply apply. Okay, so lambda x, and I try to like this. Now let me try to show how do you apply this, right? So my list is equal to, right? So let me say this is the list which I am creating. Now, if at all I want to square each element in this list, right? I can apply what I can apply. I can apply the mapping technique. So how do you do the mapping technique? So this is the my function. My function of x, right, for every x in that list. In my list. So see, every number is square. In the sense, I am applying what is called as a lambda function to every element. So my function is this thing, right? Squaring thing, right? Apply that function. This is what you already know. It's a list comprehension, and we are trying to apply the map rule here. For everything, I'm trying to apply. Okay, hope this is clear. All right, let me know if you have any doubt, right? Anything you want to discuss from yesterday's material, yesterday's class, or the exercises which is given at the end? Because I clearly mentioned that you have to go through the exercises to understand each and every concept that has been discussed, right? Over there, right? If you have any doubt, please go ahead. Otherwise, we'll move on.